Welcome to the Chapter 6.2 lesson video. Today we're going to talk about graphing something called a rational expression. So a rational expression, and this might be something that we got to keep track of and pay attention to a little bit, is when we're going to have our x value in the denominator. All right, so this may look similar to some other stuff we've done, but the main difference is now the x value is going to be in the denominator, and that's how you know it's a rational expression. All right, so we're going to be able to graph rational expressions, translate them, and sort of see how they interact. It's similar to the other things we have done this year with left-right shifts and up-down shifts, but it's a little bit different because this time we're not going to have a critical point. All right, so let's go ahead. Let's talk about these key features here. We'll go over them for just a second, and then we'll do a couple practice problems in this video as well. All right, so our first thing here is our a value. So our a value, the number in the numerator, so it's going to be just a number in the numerator, it's going to determine where the graph is. So if you look at this little graph picture that we have down here at the bottom, you can see that it kind of has two parts. It has a top part and a bottom part. It has these two dashed lines. These are what we call asymptotes. These asymptotes are kind of like force fields. Our lines can get close to it, but they can never touch them. And that a value up top, it determines where or what quadrants of the asymptotes we're in. So we're always going to be diagonal from each other, and we're either going to be the top right and bottom left, or the top left and bottom right. So let's go ahead and let's talk about that. So if we have a positive a value, then it means that our rational function is going to be in the top right and bottom left. All right, so top right, bottom left, that's this sort of basic example we have over here. There's a positive 1 on top, so the graph is in the top right and the bottom left. If it is a negative a value, then it essentially just flips that. So a negative a value causes us to be in the top left and bottom right. Right? So based on whether that number is positive or negative, it's going to help us see what kind of quadrants we are. Now that a value, it also affects how kind of, shall we say, narrow and wide these lines might be. But for our sketches, we don't really worry about that for those purposes. All right. The second piece, so x minus h, that should look really familiar. That's kind of been in every one of our parent graphs so far, except this time that doesn't move a point. What it does is it moves this blue dashed line. It moves that asymptote left and right. So same rules as always. A positive h value moves you to the left, whereas a negative h value moves you to the right. But this time we're not moving a point, we're moving that whole asymptote, that whole sort of force field where we're going to draw these lines. And then lastly, our k value, same rules as before. Positive k moves up, negative k moves down, and once again, just like the horizontal movement, that moves this red line right here up and down. So it's going to move that asymptote. So one way you can kind of think about this is where the two asymptotes crisscross is kind of a critical point, right? It's the left-right movement and the up-down movement intersection. But we really end up drawing these asymptotes. So when we're drawing this graph, I'm not so much looking for a critical point anymore. I'm now looking for these asymptotes we have drawn here. All right, so this is our basic graph, y equals 1 over x. The asymptotes are x equals 0 and y equals 0, right? Because there was no left-right shift and no up-down shift, so they're just on the x and y axis. If possible, you can plug in for a y-intercept. This is why it says if possible, because in this graph in particular, there is no y-intercept. So really, we don't worry about the y-intercept as much. What I'm really looking for is, do you have the intercepts where they're supposed to be, left, right, up, down? And then do you have it in the top right, bottom left, or top left, bottom right, like it's supposed to be? All right, let's go ahead and do some practice problems with this. All right, so I have 3 practice problems for us designed here. We'll sketch each of them. They're pretty straightforward, and I'll kind of demonstrate them for you, and we'll practice some more in class. All right, so first things first, we're going to go ahead and draw our axes. Draw our axes. On this first one, we look at in the denominator x minus 4. That means I'm going to go to the right 4, so I'll put a mark it to the right 4. And then there's a plus 1 on the end. That means it's going to go up 1. So I'll put a mark at up 1. And then I'm going to go ahead and draw my asymptotes in. Now I'm going to draw them all in the same color. I'm not going to worry about red versus blue this time. So just at these two spots, I'm going to draw some dashed lines right through them. Dash, 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 dash. Sorry, changed the color by accident. Dash, 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 dash. All right, and then we look up at the numerator. It is a positive 1, so that tells me my graph has to be in the top right and bottom left of the asymptotes, not of the graph, of the asymptotes. So it kind of moves with the dashed lines. So the way you draw it is you start really close to the dashed line up top, you kind of curve down and around, and then stay really close going down. You start really close over here, curve it down and around, right? So we don't get too close to this intersection, kind of leave a little bit of room, kind of like you have a little bit of a diagonal right there. And there's your graph, not too bad. Okay, let's try another one. All right, so we'll draw our axes again. All right, we have 2 over x minus 3, so I know I'm going to go down 3, negative 3, and then there is no left-right shift. So when I'll draw my asymptotes in for my left-right one, it's just right on 0. So I'm just going to draw it right over the y-axis. For the negative 3, that meant that this asymptote went down 3. Now, that positive 2 on top, technically, if we were to graph this on a graphing calculator, we would see it adjusts kind of the stretch or the shrink of this graph. But all we really care about for our sketches is if it's positive or negative. Since it's positive, we know that our graph's going to get drawn in the top right. So I'll draw it in the top right. And then diagonal to that would be the bottom left. And there's my graph. If you want to extend your asymptotes down a little bit, that's fine. Just make sure that when you're drawing these, they don't ever cross over. They kind of have to stay within the bounds of those asymptotes. All right, and then I have one last problem. My one last problem is over here. All right, so I have x plus 7 on bottom, so that means I'm going to go left to negative 7. Positive 1 for the k, so that means I go up 1. I'll go ahead and draw my asymptotes in, so I'll go dash, 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 dash. I'll go dash, 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 dash. All right, and then I notice on top, this one's a little different. I have a minus 5 this time. So rather than being the top right, now it's going to be the top left. So I'll draw it in the top left. Once again, once you draw it, if you want to extend your asymptote a little bit, so that way it kind of stays inside, that's fine. And then I'm going to go diagonal to that, so bottom right. They're always diagonal from each other. All right, and there we go. All right, so that's what our graphs would look like. Really similar to a lot of the stuff we've been doing with parent graphs. It's just the main difference now is we're not really moving a point around as much as we're moving these asymptotes around. And you need to draw those asymptotes. That's what I'm looking for. And then I'm looking for, is it top right, bottom left, or top left, bottom right? All right, one last type of problem that we could come across is something like this, where it says rewrite in a graphing form and then graph. Well, this is a little confusing. How do I get it into that graphing form? How do I get it to look like what those last problems looked like? And what you're going to do is you're going to use your synthetic or long division process. Whichever one you are most comfortable with, you're going to go ahead and use that method. I'm going to use synthetic, or actually, I'm going to use long division just because that's what I feel like doing this time. So we'll go x minus 3, and we'll go like that, and we'll go 7x plus 4. And then we'll say, all right, I have how many times, or what do I have to multiply x by to get 7x? I can multiply by 7. 7 times x is 7x. 7 times negative 3 is negative 21. Make everything opposite. So I'll go opposite, opposite. You could have used synthetic, whatever method you are most comfortable with. 21 plus 4 is 25. 25 up, nothing to drop down. So what we end up with is we end up with 7 plus 25 over what we were dividing by x minus 3. And you'll notice that that kind of looks like what we were just graphing, just maybe flipped around. So we'll rewrite this over here. We'll rewrite it as f of x equals 25, positive number on top, over x minus 3 plus 7. Hey, this is just exactly in the form we were doing. And I just did my synthetic or long division that we learned in chapter 3. And I then wrote my answer, 7 plus the remainder over what I divided by, and then I just flopped it around so that way it was in the correct order for what we were graphing our rational expressions as. That's great, that's fantastic. I can now draw my axes, just like we did just a second ago. -3 on bottom, so that means I'm going to go to the right 3. +7 means up 7. I'll go ahead and draw my asymptotes in. +25 on top, so I'll draw in the top right and bottom left sections of my asymptotes. All right. So yeah, so if we get something in this kind of polynomial division form, we can use one of those skills we learned before to rewrite it as a rational parent graph, and then we can graph our rational parent graph just like we did. All right. With that, you should have enough information to be able to get started on the assignment. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session, and until then, I hope you have a great day.